to your classrooms for a learning immersion through this wired masterclass. So, to give a heads on, we have given the topic as living and dying by data. Data is I would say, the new oil or the new gold, and it has the ability to change lives, jobs, companies, markets, politics, probably even the nation. There is a quote which says, all it takes to revolutionize education for the future is a few million lines of software codes and big piles of digital data. Am I right, sir? And this is the future tomorrow. So, the science of data is the most admired faculty of study in the world today, and we have with us one of India's top data scientists, Dr. Sri Ramamurthy, who is the CEO and Chief Scientist at Quadritics, to take us through this class on which what is data science, how does it transform everything in the world today, and how can we use it for our own good and for the good of the society. Added, how data science as a field could create the opportunities today as a career for, that would be more interesting for, students like you all. Having said that, it's my pleasure to introduce Dr. Sri Ramamurthy. He's got a long profile, I'm just making it short. Dr. Sri Ramamurthy is an experienced data scientist, a globally respected mentor in artificial intelligence, machine learning, big data, and automation, and a successful serial entrepreneur with experience spanning 3 decades. Dr. Murthy has been recognized as the first Indian to earn a doctorate in machine learning from the Johns Hopkins University. Over the past 25 years, Dr. Murthy has applied data science to hundreds of problems across industries, functions, and geographies. Some recent examples of his teamwork include real-time fraud detection in banking, data-centric determination of the side effects of the drug use, information extraction from videos, artificial intelligence for fashion and styling, serendipitous placement of advertisement, and the list goes on and on and on. The AI-driven digital transformation of massive enterprises, extraction and validation of information from judicial and financial documents, and I get tired reading the list of the areas that he's working with. Another distinguishing feature of Dr. Murthy's career has been the ability to foresee new applications in artificial intelligence, machine learning, and big data many years ahead of the market. So his image and text analytics work with Hubble Space Telescope, sophisticated computer-aided medical diagnosis systems, use of machine learning for individualized teaching and vocational skills, plus entrepreneurial activities on all-centric logistics, digital rights management, and data compression. So he's been invited as a speaker, as we all know, in many prestigious forums like the Trilateral Commission, the US-India Forum, and the CIA National Summits, Concordia Summits, etc. So his deep passion for teaching and mentoring has earned him the distinction of being among the 10 most prominent analytics academicians in India. Dr. Murthy has physically taught thousands of data science professionals and conducted scores of senior management mentoring. So, he lives in India and works around the world, spending his spare time in yoga, music, and literature. It's an honor and delight for us to have you as our first speaker. So, let's put our hands together for Dr. Sri Ramamurthy, and we are waiting to hear from you, sir. Welcome. Thank you.
Thank you very much, such a pleasure to open this great event with this masterclass. I'll try and make it interesting to all of you. Although it is a masterclass, it's not going to be academic in nature. My perspective is it comes from applying data-related techniques to different domains. So I'll try and sort of give you a sense of what I think data is, and that could be a starting point for your own explorations in this space. And thank you very much for such a kind and long introduction. Let me move to the topic at hand, living and dying by data. I think it's not just on how useful data is today, but for the future, data, without data, making decisions will just be impractical, is something that I would like to convey or communicate to you today. The first observation is that data is an unlimited natural resource. It's actually better than oil or gold because it's not limited. You can generate as much data as possible. Our ability to record and store and process data is what is limiting, not our ability to generate data. Our ability to generate data is infinite. And let me give you so in that sense, I think that it's more like a musical note or a sound than oil. And I'll take that simile a little forward. If you consider, for example, a bird in flight, and if your goal is to design future aircraft, looking at how, very energy efficient, lightweight objects can fly so well in nature, entities can fly so well in the nature, the way that you would learn from that entity, the bird, is by recording the data from its flight in as much granularity as possible. Likewise, a baby growing up, or a factory in operation, or a stock, or a city in motion, everything from an individual bird to a city at any scale, all are making data. In fact, I would go one step further to say that all are data. So, understanding a existing system requires us to record data about it. Modifying that system requires us to analyze that data, see what we want to improve, and then redesigning it. So it's actually a cycle of data. And so what if it's data? I mean, are we not using it currently? As human beings, we use data all the time. Maybe not in formal ways. Maybe we have our shortcuts of dealing with data. But here, I'm asking a simple question. Through regular software programming, I would like to accomplish this task. Identify items which will have the least sales in a clothes store next week, and suggest how best to improve their sale. Okay? Guess which items are going to sell the least and improve their sales. This is clearly not a step-by-step task. This is not a task for which you have a flow chart of how to do. It depends on past experience. Depending on the season, depending on the city that you are in, depending on the time of the year, the weather, whatever, what would sell well, what would not sell well, and then what may be the best way to improve those sales. So this is something that comes from experience, of that field, of that domain. Data is nothing but recorded experience. In one way, whatever we have observed, either a human being doing or a transactional system, in this case sales, recording what has happened there, or trends, fashion trends, seasons, weather, recording all of that data, and from that, answering questions like these is something that we will need to do going forward. I mean, we have started over the last couple of decades active use of data in different non-algorithmic. This is non-systematic, non-step-by-step tasks. Using data has started and it is increasing. We are scratching the surface now, but there's a lot more that needs to be done. And these are the types of problems that I would like to go into and see how data can be used. And there are different areas that we can bring to bear to use this data. Another example here, let's say I want to take the city of Bombay, calculate total distance traveled by every bus route along with its fuel requirements. This is something we can do by step-by-step calculation. We don't need data for this. Some basic data about what buses are there, how many routes, etc. But if those inputs are there, we can calculate how much distance is traveled or what is the fuel. However, if I ask you for next year, identify the routes in the city that will be the most expensive to run or the least profitable to run, then that would require understanding many more sources of data. Maybe it's to do with traffic, maybe the growth sectors in the city, growth regions in the city, many more data sets, and it also involves prediction of what is going to happen next year. So with data, it's not just understanding the data that we have currently, but also going to the next stage and saying what is likely to happen, and then the next question of if this happens, what can I do to improve? So 3 questions. First is what has happened. Okay? This, the technical term that is used is descriptive analytics. So what has happened? The next question is what is going to happen? And people have referred to this as predictive analytics or predictive sciences. Here in data science, that's a predictive part. Then the third question, let's say the second question tells you that 20% of the routes are going to be not going to be profitable next year. Then the next question you ask is, what can I do to make them profitable? So that's called prescriptive analytics. So from descriptive to predictive to prescriptive, it's a progression of understanding the system and intervening in systems. And what we see is that if we make decisions using data, then it has certain advantages compared to just step-by-step calculations. One is that we can be more adaptive because we are doing it on the basis of data. Let us say that there is a way to, let's say, diagnose a disease in a particular geography. If we are doing that diagnosis on the basis of a few rules, if we change the geography, maybe those rules will only be partly applicable, won't be fully applicable. However, if we are making that decision based on, let's say, patient characteristics or data, patient data in that region, even if we move to a new area, when the set of patients change, automatically the decisions we make will change because we extract those decisions from the data. In that sense, data-centric decision-making would be more accurate, more relevant, more adaptive, and so on. Less costly to maintain as well, because you have the decision is being extracted directly out of data. So once you have a system that can extract the decision out of data, then moving to a new area just means running the system again on the new data. It doesn't involve a lot of modification from that involves human expertise or human time. It's because of this reason that we are seeing an enormous change in the way different areas of human activity, business or other activities, we are seeing a big change in the way that decisions are being taken in these areas. In industrial production, if we just take that as an example, today we not only want to have physical factories, but we want to have a data model of that physical factory. So if I have multiple machines that connect on, let's say, an assembly line, then we would like models of those on how they interact with each other, how they modify different parameters. We would like to have that digitally so that various things about the factory can be simulated beforehand. So if a machine has downtime, how does it affect my productivity? If a new investment needs to be made, what is the best place to make it? These decisions can be done much more accurately than before, or with much more fine-grained analysis than before, if we have these data models. So we are looking at factories as, with their data sort of equivalents. We are looking at human, with health. We are looking at, the human genome, or writing out a person's characteristics in the form of their chromosomes, and then analyzing the person or analyzing impact of different pharmaceuticals on that person in the data model. So what used to be physical activities before are becoming physical plus data activities now. Astronomy, one example that was given in the introduction, previously a good percentage of astronomers used to spend their time with telescopes, physical images, analysis, and so on. Today, it's probably 10–15% of astrologers that actually collect and record the data. The rest, 85 to 90%, just work with that data. Same with biology. Data is getting sort of baked into different fields. You have schools that are coming up. About a few months ago, MIT had announced that they want a school that bakes in AI and data science into different disciplines like physics, chemistry, physical disciplines. And even if you see agriculture, that's so important for our nation, data is making so much of an impact in an area like this, in a sector like this. What data do you see in this image? You have the maybe the weather data. You have the pictures of the of the field, of the trees. If we zoom onto that, maybe we have characteristics of the plants, the growth, amount of growth of the plant, and you have soil. Maybe from the color of the soil, there are certain things that you can infer, and then if you have probes that are in that soil, then there is more data that you can get, so on and so forth. There is a wealth of data in agriculture which is currently being utilized to predict yield, to plan nutrients better, to have faster interventions in the case of a pest attack and so on, or even to do pricing of commodities. If we know what part of the, let's say, land in a particular region of the country is being, a certain crop is planted in that area, based on that, we are able to determine intelligently what should be the pricing of that commodity in the coming season, or what should be the seed prices, what should be the subsidies, what should be the fertilizer usage, so on and so forth. So even fields that are, or sectors that are considered very physical and away from technology are becoming very, very data-centric. And in any system, I mean, this is an agricultural example, but the definition is true for any system. I just want to define what is data. Data describes the systems that are in place. System may be, like say, in this hall, the systems are, the people who have come here, the infrastructure, the processes that we are following for, let us say, conducting this seminar, etc. So the entities and processes generate data. The experience, past experience, how many 9 o'clock sessions did we have in the past 5 years in this hall, and what was the attendance of that, what were the topics of that, etc. There's past experience data. Then there is interaction data. Let's say, what was delivered, how many questions were asked, so on and so forth, interaction data. And then the outcomes. Was that a well-attended seminar? Was that a liked seminar? What were the outcomes? I mean, if there were interviews here, what are the outcomes of that interviews, etc. So in any system, we can look at in any sector or in any field of human activity, we can look at the systems, the experience, the interactions and outcomes, and all of them can be written down as data. And once you have that, then modeling it, simulating it, predicting it, prescribing new things to do, what are the right interventions, all of that becomes facilitated by the presence of this data. Now, a good question to ask at that time is it all data? I mean, or do we have something more? In future, are systems going to be run just by data, or are there going to be other pieces of information that we need to bring in? Well, it's not going to be all data, because we are, even when you and I encounter a brand new situation about which we do not have much data stored, we have never encountered that before, still we are able to use our intelligence to do some reasonable, intelligent action. Okay? Sometimes it may succeed, sometimes it may not, but still we are able to take actions. The other thing is, if you have systems purely dependent on past data, how do they show creativity? Is creativity also a data-centric function, or is there something more to creativity? These are questions that come in when you study data science, and there are types of methods that are applied to different areas to combine what we garner from the data with creative variations of those. Even nature gives a lot of importance to data. When an organism evolves over a period of time, you know that 99% of the genome is the same between us and, let's say, chimps. So data is maintained, but then there are variations. There are random variations, intelligent variations that are done to that data in order to bring in evolution, creativity, etc. And that's the same case with algorithms or with methods that we follow to take care of different fields of human activity. So it's a combination of data and creativity that needs to be brought in. Okay. And in that sense, we will talk a little bit about artificial intelligence and how that plays a role. I think it's obvious by this time, I hope, that things improve when data is leveraged. Things, in the sense, decision-making improves when you have access to the right data at the right time. Decision-making cannot be completely determined by data. There is an aspect of decision-making that has to be above and beyond data, but data does help significantly in making the right decisions. A few things that it helps is in democratizing the decision-making. There are many areas where only the experienced people get to take the bigger decisions. That need not be the case going forward, especially, the youth should be able to take very, very responsible decisions in large contexts that impact thousands, millions of people. That can be done if you have the right data available to you about the past. You don't have to wait 15 years to gain experience to take the right decision. You can get access to that upfront. So democratizing decision-making is one thing that data does. And the other is speeding up decision-making. Many a time it is trial and error. Let's say if I'm responsible for placing ATMs of a bank in a new city or in a city that the bank has just entered, there's a lot of analysis that I need to do to determine what is the right place to put the ATM. Okay? It may involve population densities, where are the commercial areas, where are the residential areas, what is the amount of transactions that other banks are experiencing in that area, traffic issues, crime rate issues, etc. Taking all of that into consideration, I decide to place the ATM at a particular location. Maybe that doesn't work, then there's a trial and error, we roll back. So there's a lot of work that is done, especially in terms of taking a decision, rolling it back, taking it again, etc. And you see this in different realms of human activity. And by having the right data available at the right time, the decision cycle is speeded up. Trial and error gets reduced. So today you have systems, big data-based, what-if analysis systems that banks use, which, where you can ask the question, what if I place the ATM here? Can you predict the amount of, let's say, delays, runouts of money, or the volume of transactions that happen there? And you predict that on the basis of a data science system, and that makes your decision-making much faster, because you can just play with the data and then take the right decision. So when data is leveraged, things improve. And a comment on this, why are we talking about all this now? because it has implications in terms of cost, in terms of people training, etc., for the industry. I mean, if you look at the industry today, a lot of effort is being spent on preparing the industry for rolling out data-centric decision-making throughout the organization. It involves, number one, training people, but number two, setting up the right kind of storage systems. Sometimes you hear these terms, data lakes, data warehouses, data marts. So people are setting up these systems and then setting the right kind of algorithms, data science methods, artificial intelligence methods, and so on. The reason all of this is happening is because our ability to record data has increased, has been increasing, and we are at a place where our ability to record data is far ahead of our ability to store and process it. So if you take CERN, for example, the Central European Research Network, where the boson and other things were invented, there are particles that are colliding, and there are cameras, typically hundreds of millions of cameras, that are taking hundreds of thousands of pictures every second on the way that the particles are interacting, colliding, and going away. So hundreds of thousands of pictures taken every second by each sensor, and there are hundreds of millions of such sensors. So this is a lot of data. We do not know how to store it yet. We do not have the storage mechanisms, but we know how to produce that data. So today, our ability to produce data, if it is here, our ability to store it is some hundreds of thousands of times less than that. So you have a lot of research that's going on in newer ways of storing data, more efficient ways of processing data, even how to forget data. Because you may record data, but much of it may not be relevant to you. So one of the things that we do very well with this little, processing equipment we have, and which is very, very power efficient, we are able to deal with the world with whatever limited hardware we have. And the reason is because we know very well how to forget things, what not to give importance to. And that's not something that data science has done a lot of, but there is research going on there. I'm just showing you here the amount of data. If you go up this curve from numbers, when you go to text, it's about 100 times more. From text, you go to images, it's another 10 times more. From those images, as you go to video and then high-resolution video, millions of times more data is generated for the same, let's say, duration of event. So if I just record the audio of this conference versus I take a high-definition video of this event, same duration, the amount of data is several thousand times larger. So we need to have a way, if we want to process that video, let's say if you want to just process this to know how many people have come in, whether the front benches were used better or the back benches were used more actively, whether more questions came from the left of the room, right of the room, such things. Even if you respect people's privacy, you don't have to record their faces, but you can get a lot of information from the video while respecting people's privacy. If you want to extract that, then it's important for us to have mechanisms to store, to process that data. And, now amount of unstructured data, by unstructured data, we just mean things that are not numbers and tables, things which are audio, video, logs and various other types of data that comes under unstructured, and unstructured data is much larger today. And I'm throwing these terms, I won't spend too much time on it. I just want to say that the variety of data has increased, the types of data that we record. Previously, organizations were storing documents. So let's say if 25 years ago I went to a bank, they had 20 years ago, they had a system where they recorded the transactions. And I also submitted my, ID. I submitted some documents. Those were stored away in some files, and they were not available online to make decisions about me. Today, that's not the case. All the data that I'm submitting ideally should be available online to make a decision. Same with the retail store, same with different businesses. So variety of data that we are capturing has increased. Veracity, that is the truthfulness of the data. How dependable is the data? There's a lot of complexity there. So let's say I want to understand one of my customers, and they give me access to their Twitter feed, or they give me access to their Facebook page, okay? And how much can I rely on that data? maybe much less than what I can rely on a transaction that they have done with me, which is, let's say, if I have access to a financial transaction they did with me, that's probably more reliable than the other. So this access of reliability of data becomes important, and you want to design methods that work reliably in the absence of reliable data also, right? There's data, and there are methods that are working on it. Even if the reliability of data is low, you want to design methods that perform well. And that's an area that is part of data science. So even with probabilistic data, even with uncertain data, you want to be able to take reasonably certain decisions. Okay, let's say I want to hire somebody. Okay, in HR, we are trying to hire somebody into an organization. Then when they come in, not sure if all the information they give to me is right, but still I would like to be able to make the right decision in terms of hiring, not hiring, or placing them at a particular position. So data in doubt, uncertainty is an important issue. And I just want to point out that, see, one is, I said we can produce more data than we can store and process. The second is, of the data that we can store and process, what we today process, or what we today extract insight out of. From data you get to insight. Okay, data is, let's say, all video, audio, attendance of this room, of this session, is the data we have. And the insight is that if it is a 9 a.m. session on a Monday morning, then the number of people in this age range will be more than the number of people in this age range. That's an insight. So from data, you want to get to insight. From insight, you want to get to automation. The reason you want insight is because then some of the decisions, it may be possible to partially or fully automate, right? So our ability to record data is less than our ability, generate data is less than our ability to process it. And the insights that we extract today are just superficial. As a field, that's why this is so exciting, because there's so much that has not yet been done. And as you start exploring the area, you will see that so much has not been done yet. So it's a greenfield area, data science. That's why it's such an exciting field. So today, most of the insight, let's say 40 to 50% of the insight, half of the insight, comes from about 10%, 15% of the data, which is the structured data. From all the rest of the data, we hardly get 20% of the insight that we have. So let's say if we have a question of what happened, let's say we are looking at a retail business. We want to look at, let's say, I don't know, some Reliance stores. And we want to know which parts of Bombay sold better than the other parts. This is a what happened question. What happened question typically comes from structured data, tables of data. That, so many people bought, this is the total revenue that the shop earned, etc. Then, the next natural question that we would ask is, why did it happen? The answer to why lies in the unstructured data. The answer to what lies in the structured data. Why did it happen? Because, from the surveillance cameras at the store, we saw that the volume of people that came in has really come down on Wednesdays. So why did that happen? You go further, Wednesdays, the traffic seems to be, very, very bad in the area that the sales came down. Why did that happen? So all these sequence of why questions are actually answered by unstructured data. The answers lie within unstructured data. So that's why, no matter what organization we belong to or we're going to work in, etc., it is absolutely important that they store all the touch point, all the data that they have with their customers, with their products, with their stakeholders, and process that to answer these questions. That's how you gain insight into the business. What insights come from structured data? Why insights from the unstructured data? The other point I want to make about data is that data has to be leveraged at different levels. Simple, I talked about descriptive, predictive, and prescriptive analytics. Okay, analytics is essentially analyzing the data, understanding the patterns in that data, etc. Another way of looking at, different levels of usage of the data is, at the topmost level, you may just be reporting or, producing some MIS report, management information system reports. Then there could be drill down dashboards which say that, sales in Western Bombay were down, and in Western Bombay, if you go down to individual regions, these are the regions that did well, didn't do well, etc. And then you go into predictive models, and from there to what-if analysis, from there to process design based on data, and then finally to automation, intelligent automation. Like today, for example, in a call center, we have systems that are monitoring a call that is happening between a call center agent and a customer, and to identify in real time call center agents that may not be handling the call right, may not be allowing the person to talk, who may be talking at the same time as the customer, and this can be very easily detected from the audio. And if the supervisor, or if a screen is there in front of the call center agent which says, slow down, let the person talk, then that'll improve the quality of that call. Next level, if we know what kind of conversations are happening, maybe we realize that 70% of all calls are routine calls, they're repetitive calls in the call center. So maybe an AI agent can handle it much better in a more predictable way. And the AI agent should also be programmed in such a way that if it cannot handle the call, then seamlessly it escalates it to a human. So call centers which are made up of partially robots that are answering calls and partially humans that are taking the more complex calls. This is a reality. This is happening. In the BPO, KPO industry, we know that there's going to be a lot of impact of data science, a lot of impact of artificial intelligence to handle issues like this. Let me move and introduce these terms a little bit. I've been saying artificial intelligence, machine learning, etc. But what I'm doing on this slide is just putting things in their place, in a perspective. Data science is the overall umbrella area. Okay, this is the outside rectangle. In that data science, there are three major pieces that you see here. One is statistics, one is artificial intelligence, and below you see a big data box. Okay, when people say big data, what they mean is data that doesn't fit on a single computer. So you need to fit it on multiple computers and somehow figure out how to make these computers coordinate and perform an operation as though they were a large computer. So big data is an engineering issue. Big data is needed whether you're doing AI, whether you're doing deep learning, machine learning, whatever. The area of big data is the engineering of how to store a lot of data, how to process a lot of data, and do it fast and cheaply. That engineering aspects come under big data piece. Statistics has been there for a long time, several hundred years, and techniques from statistics have been borrowed into artificial intelligence, into machine learning techniques, concepts have been borrowed into AI, machine learning. But the difference is that AI, which started about 70 years ago, AI as a field started about 70 years ago, and it went through multiple generations. The idea was that, human beings were fascinated with intelligence around them. A child is born and within no time starts to walk, within no time starts to talk, and does such intelligent things. It's a delight to watch intelligent behavior. It's a delight to watch biological systems learn. Little ants quickly coordinate and get, the food that they need to. Bees coordinate so well. So on and so forth. Evolution in general, whether it's in flora or fauna, there's so much intelligence in nature around us. So artificial intelligence started as an area to mimic the intelligence in the nature. So if I can build drones that can coordinate as well as ants, That's fantastic, right? So AI, the goal is systems that exhibit intelligence akin to that of living things. The only intelligence we know is of living things. The only intelligence we have observed, our own intelligence as well as of other living things. So the idea is, can we build systems that do the same thing? So an expert, let's say, painter, is able to come up with a new style. Can I have a deep learning network that can come up with a new style of painting? An expert music director does fantastic tunes. Can I do an AI system that does new and believable tunes? A smart person is able to tell a great joke. Can I build an AI program that can tell a great joke? So it's mimicking of intelligent behavior. As part of that, there is a subfield called machine learning, which is building systems that improve themselves. This is something we see with all living things again. They learn and get better. So can we have an Excel sheet that gets better over time? Can we have a, let's say, a mobile app that a bank gives you, which learns that, you normally do 3 types of transactions. You don't need all those complex interfaces, so directly gives you what you need. Can we have we know all this, a music system that learns what you like? That's machine learning. Systems that get more adaptive, better with time. So machine learning is a subset of AI. In machine learning, the set of methods that are the most popular now are deep learning methods, which sort of try to mimic neural networks, that biological neural networks that we have. Approximations of that, simplifications of that are created as artificial neural networks, and these artificial neural networks are what we learn from in the deep learning methods. So I won't go into technical things, but the other important part of AI is human-like interfaces. You and I communicate in a particular way. You're looking at me, I'm making gestures, I'm talking, you're listening, so on. So there is no reason why computers should not be doing the same thing. The initial stages, adolescence of computing, we may have mouses and clicks and keyboards, but going forward, we should not have those. Going forward, computer systems should be integrated into the physical world so that humans can communicate the way they are comfortable, and machines should learn to communicate in the same way or understand the same way. And we are seeing that happening to a certain extent. We still do not have tactile much. We do not have haptic, which is the sense of touch. We do not have smells. Olfactory sense is not that mature in computing systems. But we have vision and hearing that's getting better for programs. That also comes under artificial intelligence. That whole human-like interfaces comes under that. And there are other technologies like planning, game playing, intuition, imagination, things that human beings do very well, empathy. There are people in AI world that worry about such things, and what is the mechanism of empathy? So neurally, is there a mechanism of empathy? And some of you may be familiar, but there's a lot of work that goes on. What is the mechanism of imagination? Is it just, combining in different ways what we have already seen, or is there something new? So some of the techniques, some of the things that we observe in the biological world or the world of living things, we still do not have enough, most of what we observe, we still do not have machine implementations, but there are a few things we figured out which happen to be very valuable in industry, right? In interfaces, for example, if it's human-like interfaces, you can imagine hands-free computing, you can be much more productive at your work, and there are certain things that machines can do, etc. Will this have implications? Absolutely. Job market implications, education implications, etc. Those are not to be ignored. So we, as people that are interested in new technologies, should also be aware of social implications and design systems so that they are suited for our geography, our requirements, our society's requirements. Because any technology, data, technology, etc., it's useful if it makes lives better. Otherwise, there is not much point to that technology. Technology for technology's sake is not very thrilling. But if it makes lives better, it's great. So the challenge that is there in data science today is how do we design systems? I mean, if you're taking India, for example, India specifically, how do we design systems here that will make India a better place? So if implementing AI algorithms means that 40% people will lose jobs, clearly that's not a very smart way of developing technology. So are there new things that can be created? So there are many discussions. I mean, unfortunately, we have only 1 hour, but there are many issues there we need to go into to define things, to define technologies, to develop technologies that are pertinent for that geography. And India did very well in these, in previous industrial revolutions, in the sense that overall GDP or quality of life indices have gone up. If you take, I'm talking in a larger scale of, let's say, last 100 years. AI also should do that, increase the quality of life that we have. So what are the technologies that we should focus on? What are specifically relevant for India? Like translations are, in terms of AI, we are a multilingual society. So ideally, we should just make language a non-factor. So that I speak in any language, you understand in your language. Right? AI can do those. So let me just close with just a statement that there is no magic about AI. It is just like computer software. And I want to say this with an example. Let's say you are a auto insurance company and you want to know how many accidents will there be, how many claims will there be next year. Because if you know how many claims are going to be there, then you can decide your pricing accordingly, you can decide your service accordingly. So to guess how many claims there will be, all the AI system does is this. Let's say they have 1 million customers and there are 100 types of cars, and each car is anywhere from 1 to 10 years old. Each customer lives in one of 1,000 localities. Each locality has past accident rates, weather patterns, crime rates. Based on all of these factors, when you combine them, there are billions of possible combinations, right? The AI system efficiently searches through those billions of combinations to find or to give you the confidence that next year the number of claims filed will be somewhere between 26,000 and 28,000. Because it evaluates all those billions of combinations and puts a score on each of them and gives you what it finds from those combinations of data. So really it's just doing mathematical combinations. There's no underlying magic. Under the hood, it's just fast search through millions of combinations. That's what AI systems do. Okay? There's a lot more that can be said, but let me pause here and ask for some questions, if there are any. There are many opportunities. Oh, just one thing I want to comment, one last thing is, there are many new job opportunities that are being created. Let me quickly go to that slide. This particular slide, so every row in this, domain knowledge, these are a set of positions, subject matter experts as people are called, where you understand that domain and you can help a data scientist design the right model. Because unless you know pharmaceutical industry, how will the data scientist make mathematical models relevant to the pharma industry? Similarly, data collection, there's a whole set of jobs in data collection, designing sensors, designing databases, maintaining data lakes, etc. Whole set of jobs that are in the data infrastructure space. These are like running cloud infrastructures, security of those infrastructures, sharing of those infrastructures, etc. Data pre-processing, there are a variety of visualization skill sets that are required. There are many tools, and there is engineering that needs to be done, so software engineering on data processing. And then there is algorithms, people that know math, people that can design new algorithms, understand existing algorithms, pick the right algorithms to use in a particular AI application. There are a set of jobs there. These are the guys that are normally referred to as data scientists. And then there are people that specialize in how to process text, how to process image or video, how to process logs, etc. There are sets of jobs in those areas. Then how to present all that we have found from the data, because it involves being able to relate it to the business problem and talk to a business user that this is how your data, this is what your data